Ladies and gentlemen, it's my pleasure to be here today because I haven't been at Embedded World for a while, and so it's great to be back. And also, thanks to Farnell for the invitation, by the way. After that, at the booth of Farnell, we're going to do a small meet and greet. So if you have questions and so on, please swing by. So, my name is Dominik Bösler. Why am I bringing this up? It's actually because I'm a geek, I have to admit it. I love everything that has to do with technology, comics. I collect Iron Man figurines, very much to the distaste of my wife. But yeah, so this is why I love to bring this up. And I cannot wait until something like this is becoming reality. So this is from Ghost in the Shell. So when can we transfer human minds into robotic bodies? Do we want to do that? Should that be possible? About things like that, we're going to talk today. Apart from doing presentations, I'm also working with the United Nations. We're currently analyzing in a working group, how does technology affect the achievements of the SDGs? So you might know that there are these 17 Sustainable Development Goals, and you can look at the fact if technology is helping to achieve them or if it's inhibiting to achieve them. To be honest, for zero hunger, it's very obvious. We will have to automate food production in order to nourish 10 billion people on this planet, and this is going to happen by 2045, most likely. For reduced inequalities, it's also easy. Technology is not really helping us unless FAMAC, Facebook, Apple, Microsoft, Amazon, Google, the whole large companies would have to open source their technology tomorrow, which they're not going to do, which would also not be feasible from an economic point of view. But for reduced inequalities on our planet, it might make sense. But if you now combine 3 or 4 of those, so for example, zero hunger with no poverty, life below water, and peace and justice, it becomes a 4-dimensional combination and it gets very complex. And so this is what we're currently trying to research. So far, my career has always been about predicting the future, and no matter which oracle you're using, so this is an Asian stick oracle, but there are different other ways to predict the future. And unfortunately, they do not work. At least, unfortunately, according to my CEOs and supervisory boards, because when I did this at Microsoft, KUKA, Festo, and other companies, they were not very happy that I couldn't tell them what they should be doing next year. On the other hand, personally, I'm very happy that this doesn't work. Because imagine you knew what would happen tomorrow. This would mean, depends on which, if you're living in a utopian idea or in a dystopian idea, it would mean that either you know about the future and you can change it, so then it's no fun anymore because everything would be predestined, or you live in a future where you know everything and you cannot change it. But this would be even more cruel because then you don't have a choice. So this fatalistic idea was around for hundreds of years. Luckily, today this is no longer true, as long as we cannot calculate the future. Because there are scientists that predict by 2060, we might be able to build a computer that can calculate the future. If this is going to be true, or if we're running into Heisenberg's uncertainty, so the physician, not the guy from Breaking Bad, you know. So, but if we run into Heisenberg's uncertainty because the computer would be calculating a future where it is part of, and it would alter the future by calculating and so on, but that would be a philosophy lecture. No worries, we're not going to do this today. Today I want to talk about technological innovation and a little bit about AI and robotics. The second thing that saved me was this. There are many examples where predicting technological progress didn't work. And this is one of those. In 1830, people believed humans die when they ride on a train because the human body is not made up for speeds of 30 kilometers an hour. Today we cannot imagine this, but at the time, this was what people believed. A little more than 125 years ago, in 1897, Lord Kelvin, the head of the Royal Society, predicted that radio has no future. Radio then became one of the most important media for 125 years. Today, in German's catastrophe response plan, it still says, when the siren sounds, by the way, tomorrow and Thursday, there is a test alarm. Don't worry, it's not the end of the world, it's just a test alarm going on. But when you hear that, you're actually supposed to turn on your radio, if you still have one. But this really evolved, and he didn't see it. You know why that one is funny? Because I heard the same things about the internet, mobile video games, now robotics, AI, and quantum. What did you have in business 35 years ago when you were the cool kid? What was the phone that you had? BlackBerry, yes. Oh, then you were in consultancy. What was the other one? Nokia, the Nokia communicator, you know, the brick that you folded up sideways with the coolest mobile game. We couldn't imagine that 12-year-old kids couldn't survive without cat videos at the bus stop. Nobody could imagine that because the internet still came from squeaky boxes. Same effect here. Well, the same here. He also said X-ray is at best a party trick. They pulled him, removed him from office after that. I don't want to come up with a causality here. But before we pick too much on the British, 2 years later, nearly the same thing in the US. Charles Duell, the head of the Patent Commission, said, everything that can be invented has already been invented. Ladies and gentlemen, 125 years ago, he wanted to stop any R&D because he believed that humanity knew everything that was out there, which is surely not true. Think of the medical domain. Antibiotics were discovered in the 1920s, pacemakers 1980s, and so much many more innovations, including that. 1936, never will a rocket leave the planet. Today they're even landing again. And here at Embedded World, most of those misconceptions come from IT. Thomas Watson, there will never be a market for more than 5 desktop computers. But you know what's sad? This year, for the first time, I had to explain that to my students, because when I talked to my bachelors, I put up that slide, and this year, for the first time, they were shrugging. They were like, yeah, and? It's only engineers and gamers that use desktops. Everything else, that is just smartphones and tablets. Yeah, sure, but that's not what he meant. He came from a time of room-filling mainframe computers, and now we're down to actually wearable computing, the RFID tag in your t-shirt talking to the washing machine. And Bill Gates, 1981, ladies and gentlemen, just 45 years ago, nobody will ever need more than 640, and now careful, kilobyte of memory. He was not talking mega, giga, tera, peta, zeta, iota byte like today. No, he was talking kilobytes. But the revenge by IBM came a year later. IBM said, who's ever going to pay more than 100 million for Microsoft has to be crazy. Because at that time, in 1982, they had the chance to buy Microsoft, and they didn't do it. Yes, today it would be 283.2 million if you look at inflation and everything, but the performance would have been much better than Bitcoin. So, unfortunately, we cannot really predict it. And this leads me to one of my most loved pictures, because this is a German inventor, Otto von Gernsbach. He invented TV glasses because he believed television would be carried out like this. He had 2-meter-long antennas. I cut them off for the picture. He looked a little bit like a Martian. But it leads to the question, what is innovation? So, who can tell me, what do you need for innovation? What do you need so that something is an innovation? Sorry? Okay. That is very good. So a market, sorry, again, the market. Yeah, a market who is interested. Okay, then I got it correctly. The market has to be interested and has to adopt your innovation. Yes, very good. Actually, I can give away, I saved the last one, the last microcontroller. It's a development board. Oh, you have to thank Farnell over at the booth. But I have other giveaways for anyone else, because there's a second element of innovation. What is the second thing? The market has to adopt it, and what else do you need? Novelty, yes. It has to be new. I just have something for you in a second. It has to be new. If it's new, it's an invention. He clearly had an invention. But he stopped at the innovation stage because it never became successful on the market. So, I have a tiny ruler for you. Sorry, no more microcontrollers, but just join us over there. So you need something new that is successful to have an innovation. Well, 80 years ago, this didn't work for him. But if he had been working for another company, maybe 80 years later, it might have been an innovation or not. Because I don't really see AR taking off yet, although I would be hoping for it because I have to wear glasses anyways. Imagine it does facial recognition, it connects it with your LinkedIn profiles. I see who you are, what you're talking about, or who's already tweeting. Oh no, we don't tweet anymore. Who's already blue skying about, oh, this is a good presentation or not, or whatever. So this would be the relevant information. And in many cases, you know, there are examples where we can't predict in advance if something is coming true. The car in the beginning didn't make much sense. Or we thought he would be crazy because we didn't want to give away the keyboards of our smartphones at the time, if we had a smartphone. Maybe in most cases, it was a dumb phone. So we didn't think that he was right, but in the end, he was. So the important sentence from the textbook is, disruptive innovation cannot be planned. It can only be recognized in retrospective. Bless you. No, basically, when you're looking back 25 years or 30 years later, you can say, yes, the car, the plane, the transistor, the internet changed the world, but I cannot get up this morning and I can prove to you that what I invent will do the same. I can try to convince you, and hopefully you're an investor, but I can't prove it. I can only prove it looking back. And unfortunately, many companies are not willing to take the risk. So in most cases, we only see incremental innovation, so things that only get a little bit better over time. The innovation of a washing machine of 1945 to 54 till 2012. Towards, we're all hunting for disruption. So things that are breathtaking like fire, electricity, the wheel, transistor, AI, robotics, and quantum, because today everything has to be quantum, you know? So, now I told you a lot that you cannot predict about the future. Well, luckily you can say something about the future. The larger the cycles are, so you cannot say anything about fashion or consumption. Well, according to my wife, I'm a particular bad judge of that. But if you're looking into economy, technology, or society, so 25 to 50 years, the mega trends, you can try to understand how the world is going to evolve. And this very nice looking gentleman wrote a great book in 1982, which was called Megatrends. And he was defining a megatrend as something that is around for at least 25 years and something that is going to affect every human on the planet. Those are the two characteristics of a megatrend. We now could do a lecture of 3 hours about all the megatrends. Unfortunately, we don't have the time, but this is a collection of the most well-known and accepted megatrends. So climate change, resource scarcity, and so on. By the way, resource scarcity not just applies to water, but also to helium, less than 20 years, and copper, less than 35 years. Everything is growing together in cities and metropolitan areas. We are concerned about safety and sustainability and so on. So there are a lot of these large-scale trends that help you to predict what is going to happen in the world, unless one day something unexpected happens. There is this tiny little container ship stuck in a canal, and the prices for your supplies skyrocket. At the time I was helping a Berlin-based startup, we put stupid cameras on stupid robots and tried to make them more intelligent with AI. My camera prices soared by 800% because we couldn't get the chips anymore. And it was not because the supplier was pulling one off on us. No, it was really that they couldn't get the chips. I had to buy them soldered out of other devices in Shenzhen in order to keep up production. So how are those called? How are these events called? I think I heard it. Disruptive? No, sorry. Black Swan. Yes, very good. I don't dare to throw that far, so can you maybe reach it back to the last row? So thank you very much. So black swans, because they're unplanned and you cannot prepare for them. Well, actually you can, but you have to do scenario techniques and then quantify the risk that might actually happen. Then there are other mega trends like individualization, the biggest driver behind Industry 4.0. We're moving towards a knowledge society. Economics powers are shifting, and you could sum it up. We are living in the Anthropocene, the human-made age. It's no longer materials or manufacturing capabilities like, Stone Age, Copper Age, Iron Age. No, it's us. It's humans. Humans are the disruptive factor that are going to shape the future. And with technology. If you look in literature, scientific literature says that Anthropocene most likely started with the first industrial revolution 140 years ago. So we have to be careful what we're doing with technology because this is affecting the world. Now I left one out. I left out the most important megatrend, which is, no, not AI, haha, that would be nice. No, AI not because it's far too young and it's not affecting every person on the planet yet. Particularly in some parts of the world where we don't have internet, we shouldn't be talking about AI yet. No, it's the demographic change, the overaging of society, or in general, the change of demographics. This is an old slide. McKinsey predicted in 2014 that by 2020, the German population, 50% of the German population will be older than 50 years. They were right. In 2020, more than 54% of the German population were older than 50 years, and it's getting worse. So there are three things we can do. Either accept that we can't keep the level of prosperity, or we can work longer, or, haha, you might have predicted it, automate. And it's not that I'm working in automation because it's not because I work in automation that I'm telling you this. It's the other way around. This is the case why I work in automation, because this is going to be the future. And we have to start with the 3D, the dull, the dirty, and the dangerous jobs. Because there are a lot of jobs out there that humans shouldn't do, that humans don't want to do, and that we're running out of people that can be doing them. Now you might say this is a nice German problem, a nice first world problem, but no, the OECD predicts that by 2045 we're going to run out of human labor on the globe, because even Asia is outsourcing to other Asian countries. After that you can go to Africa, and after Africa we simply run out of world and humans. So this is going to happen 2045, 2050, somewhere around then. And it starts, there are the first solutions. So for example, if you're building a high-rise building, you have to drill 20 or 30,000 holes in the concrete ceiling. It's a terrible job. Now there are machines to do that, but unfortunately 4-ton machines that are very expensive. So this is not cuddly household robotics that I would be wishing for, but that might be the next step. So, IT developed in 4 phases. We had miniaturization from mainframes to the desktop, then numbers exploded, machines got more expensive, we went from desktop to laptops, mobile computing. Then we went to ubiquitous systems we can carry around with us, to pervasive computing. The same thing is going to happen in automation as well. So, first of all, we had large room-filling machines, industrial robots. These industrial robots, I brought you a little video. This is actually the first manufacturing line of Ford. Ford did something unprecedented. 1 car in 90 minutes. He was not very fond of individualization, but 1 car in 90 minutes. What you're seeing behind me, well, that's Jake. He's not very interesting, but what you're seeing behind me this is the manufacturing of the body in white with Jeep Wrangler. How long do you think the manufacturing of such a body in white takes today? So 90 minutes for a car in Ford's times. How much for welding this together? Minutes, yes? How many minutes? 5, less, 3, less. It's actually 61 seconds. And there are customers that are shooting for 40 seconds. By the way, I'm only showing the KUKA videos. You could use a FANUC or ABB video as well. I don't get any money for that, sadly, but I'm allowed to use the videos, so not that you wonder. These robots are very efficient, they're accurate, but they're living behind cages. So it's a robot zoo. It's not service robotics, it's not flexible. The second revolution is going to be the moment when we uncage the robots. I've been asked about cobotics today, collaborative robots. So I brought a Bavarian application. So actually it's alcohol-free beer, don't wonder. So in every joint, this robot has sensors, and these sensors make the robot safe for human interaction. And so we uncage the robot. But at this spot, you're seeing that our engineers had too much time because they tried to get the yeast out of the bottle. But at this spot, you see that the machine is still stupid. 2 degrees too warm, the beer overflows. 2 degrees too cold, no foam. Coke bottle or water bottle, the bottle breaks. So this application is still programmed line by line by line. So it's good because it's safe, but it's not smart yet. The third step is when robots become mobile. So mobile robotics, no worries, if you want to take pictures, you get the same slide at the end again. This is, I would say, Industry 3.8. We put a robot on a wheelbase, but 25 kilograms of robot and 450 kilograms of battery. So if you want to become billionaire, a lot of energy on small space without boom. That's what we need. That's what we need for many industries. But this robot would go to the shelf if an employee was running out of small pieces and bits and would bring it to the employee, but also not smart yet. So what is the Holy Grail? The Holy Grail is when these systems become smart and intelligent. So when AI meets robotics, because we need robots that understand what we want them to do. I don't say that they have to be intelligent or that they have to have feelings, but they should at least be capable of me showing them what they should be doing. So for example, listen, to change the batteries, you unscrew this, you open it, you put the battery in. Did you understand this? Yes, I did. Okay, now do it 200,000 times. That's what we need. But that's what nobody on this planet can do yet. And I always say, because this is the gate for the love of my life, shouldn't tell my wife, but Jetson's Rosie, the robot housekeeper. You know that the introduction of the washing machine freed 30% of human time. Well, yes, we use that for cat videos and for the internet, different story. The introduction of service robotics will free again 30% of human time. So this means a robot that does the dishes, that tidies up, that cleans the house, that takes care of the chores that we don't want to do. That is more or less the Holy Grail. But we're by far not there yet. Actually, I just have to warn the organizers. I'm aware of time, but I'm going 5 minutes into Q&A. Don't worry. Because I brought you some robotic examples in order to make this a little bit more graspable. So you might have seen these things and everybody is talking about humanoids. And I do perfectly understand that people would be afraid if you go jogging in the woods and you see such a robot. By the way, from an engineering point, absolutely amazing. But from an industry point of view and from a TCO point of view, absolutely, forgive my French, bullshit. Because the problem is you only need legs in 3 cases. If you want to get over obstacles and stairs, if you're operating in chaotic environments or in the outdoors, like this robot. You also know why I'm not afraid of the robocalypse, the robot uprising. The battery of this system runs for 15 minutes. If I can run 16, I'm safe. Or they will need a very long extension cords. Yes, this will happen. This will come. In 50 years, we will see this, maybe in 30, but not in 2 or 3. It doesn't help that we see a lot of those videos because those robots are far more sporty than I am. They can do tricks that I couldn't. So it's absolutely amazing what they can do. But you're going to see in a second. So I recently talked to Mark Reibert, the CEO of Boston Dynamics, and I asked him, and he was like, we were like, hey, listen, that's great choreography, that robot moving out, that robot moving in. He was laughing because you know why they did that? because the first machine ran out of battery. So unfortunately, they had to swap robots. The other thing that they finally showed was this video. They showed the outtakes. In the making of that first video, they destroyed 8 robots. It cost them millions of dollars in 4 months of time. And that's not that I'm saying they're bad engineers. Actually, they're amazing. Oh, sorry, I don't know why the video is... Oh, sorry. Somehow it's bleeding out here. It's hitting some obstacles and so on. So it's not that they're not good engineers. They're the best engineers in this case that I know. But we're simply not there yet. It's like the beginning of cars. And by the way, about autonomous driving cars, you might have seen that as well. There's a sport with kids now in San Francisco. If you want to disable an autonomous taxi, you put a traffic cone on the front because it detects it as obstacle, it cannot remove it, and it will shut down. So unfortunately, young kids are now making fun of that. Or you might have incidents like that, so the autonomous cars are blocking themselves in. This happened at 3 a.m. 80 cars were blocking each other. Unfortunately, they all start at 3 a.m. They were bringing in 80 experts from the company to drive those taxis away because you need 1 person per car to solve this. So yeah, unfortunately, we're not there yet. I could show you more examples, but I want to quickly wrap this up. Don't get me wrong. I seriously believe that the future of robotics and AI is now. It has started today, and we are going to see this. By the way, you ladies and gentlemen, you are the last generation of robotic immigrants with very analog migration backgrounds, and you will experience 2 revolutions: the digitalization of the world and the automation of the world. So it has started today. AI will be the key. So when AI meets hardware, this will be the case. But I do not believe what Bill Gates said. Bill Gates said, a robot in every home by 2025, ladies and gentlemen, this would be today. This is not true. But you can get a vacuum cleaning robot, a floor mopping robot, a window cleaning robot, a gutter cleaning robot, a lawn mowing robot, a pool cleaning robot. This cannot be sustainable. Please help us that robotics is not becoming the new smartphone, because otherwise we will have a lot of devices that only live for a year. And I see myself in 5 years standing in the kitchen at night, eating a cookie, dropping something, 5 hatchets open, 7 robots come out and fight for the right to clean up. This cannot be the way to do. But it will be that our grandchildren grow up in daily contact with those machines. And they will not be afraid. They will see this as added value. And they will be the first generation of robotic and AI natives. And so we have to drive sustainable innovation, responsible innovation, or like Goethe said, the spirits that I've cast, my commands ignore. We have to avoid this. But I've also been asked today if I'm afraid of artificial intelligence. And ladies and gentlemen, I have to tell you, I'm far more afraid of human stupidity than artificial intelligence. Because it's not AI that's going rogue. It's the people that are going to send out AI to do bad things or to send out killer robots. And for that, I think we should take responsibility, and we need governance structures in order to avoid that here, because I don't want to see a future with the Terminator. And so I do believe we need governance structures and so on, but this would also be a different talk. And with that, well, I think I went 5 minutes over, but if you want to contact me, you find me here. If you want the slides, you find them there. And I want to thank Farnell because they invited me here today. Actually, we have a meet and greet over at their booth. It's just a green booth over there. There are nice giveaways. You can ask questions. We can get in discussion. And I thank you very much for joining me today. Enjoy the trade show. Do we have 1 minute for questions, or do we do the questions? No, we do the questions over. So if you want, just join us over there. Give me 1 minute to wrap my stuff up, and we meet over there. Thank you very much.